All right, ladies and gentlemen, we're going to talk about another theorem that's going to help us set up proportions, and this theorem's name is the angle bisector theorem. Okay? So the definition of the angle bisector theorem states if a ray bisects a triangle, then it divides the opposite side into segments whose lengths are proportional. Okay, to the lengths of the other two sides. I know that sounds confusing, but it actually is not too bad. But before we get into this, let's just make sure we know what bisects means. Okay, the word bisects is to cut equally. Okay, so if you look in our example here, if CD bisects angle ACB, so we have CD, which I'm going to highlight in red, okay, if I can, there we go, that's better. So we have ray CD, it's going to bisect angle ACB. So I'll highlight that angle, and we'll do it like in this light purple here. So if you look at this angle, so what it's saying is this ray, this line, is cutting this purple angle into two equal parts. Okay, so it's cutting it equally. So this angle C is now turned into two equal angles by this arc. When this happens, we can then set up a proportion, two fractions equal to each other. And the way we're going to set up the proportion is pretty simple. What it says is when this happens, we can take this side here, the side that's across from my bisected angle, so it's across from it, and it gets split into two segments. It says when this happens, we can now say that AD can be put into a ratio with BD. Okay, so this segment and this segment can now be put into a matching proportion or a ratio. Now, because of that, we can now create a new proportion which says we can then take CA. So notice CA comes from the same triangle as AD. So CA, which I'll highlight in purple, is now going to be in a ratio with CB. Okay? And of course, once we have a ratio, we can cross multiply this off. So in example A, we're going to set up this situation and go from there. So we're going to use the angle bisector theorem. So if you look, we have a line, a ray, or a segment in this case. And because of these two arcs here, we know that this line that I'm highlighting in purple has cut or bisected my angle B. Because of this, we can now use the angle bisector theorem, which says when this happens, we can set up this proportion. We can say AD can be put into a proportion with CD. So AD with CD, and it could be equal to, again, we got AD, so we got to get the other side of AD, which is going to be AB, over, and then we get the other side that matches with CD. So CD was from this triangle, so we're going to get CB. Okay, so that's how we set up the proportion. And of course, we can solve this by cross multiplying if we need to. All right, let's do some examples here. So our goal is to solve for P. We have, again, another angle bisector. So this guy's an angle bisector because it cut the angle into two equal parts. So I can now set up the proportion. So I can put P over 18. So P over 18 is equal to, so we got P from here, so the same triangle. We're going to get the other side, which is 14. And it's going to match with the side that came from 18, the other side, 28. All right? And we can cross multiply and solve. So we can have now cross multiply, that turns into 28p equal to 18 times 14, that gives me 252. And now we're going to solve by dividing by 28. P equals 9. All right. So go ahead and try some of these, and we'll do them together in a little bit, but pause the video, try them, and see if you can figure them out. All right, let's do example C. Our goal is to find QR. So we're trying to find this measure. So I'm going to put an X here. Okay. So again, you should notice we have an angle bisector segment right here. This angle and this angle are being cut into equal parts, so I can use my theorem. So I'm going to use X over RS. Again, I'm putting RS because we really don't know what RS is, but we're going to find out in a little bit. So RS equal to, so X came from this triangle, so that means I have to put 12 on top. Okay, RS came from this triangle, so I'm going to put 8 on the bottom. Okay, so now let's try to figure out what should RS be. So we know from here all the way to here is 18. Okay? So to figure out what RS is, we're going to take all 18 and we want to subtract away. So if you think about it, we want to subtract away R to Q. We know it's X. We know the measure's X. So when we subtract it away, what RS really is 18 subtracting away X. So we want all the way 18, but we want to subtract away this length. And that length we know is X. Okay? And this is how we get 18 minus X. So instead of RS, I'm going to plug in 18 minus X. And once we have that set up, we can cross multiply and solve. So let's do this. It's going to be this times this and this times this. So we'll go 8 times X, that's 8X, equal to 12 times 18 minus X. So keep in mind we're doing this. We've got to distribute. And now let's distribute 12 times 18. So we're doing here. That's going to be 8X equal to 216 minus 12 times X. That gives me negative 12X. And then our goal is to solve for X. So I'm going to add 12 to this side because I want to get the x's together. So add 12x. This gives me 20x equal to 216. Divide both sides by 20. And we get 10.8. Okay, so QR, which we labeled as X, is 10.8. All right, last example, find the value of X. So we recognize that we have another angle bisector here because these two angles are equal. So I want to go X over, and X has to go over this measure, which I'm going to highlight in purple again. So I'm trying to figure out this measure. We know from here to here is 21. Here to here is 21. But we don't want the entire 21. We just want up to here. So that means I want to subtract away X. Okay, so if I subtract away X, it gives us this measure here. So to write that algebraically, it's basically I want the entire 21, but I want to subtract away the X for this section. All right. So to set up this proportion using angle bisector theorem is going to be X over 21 minus X. Equal, so X came from this triangle, so we're going to get 16. 21 minus X came from this triangle, so we match it up with 12. And now we cross multiply to solve. So we have 12x equal to 16 times 21 minus x. Don't forget we're distributing here. So it's 12x equal to 336 minus 16x. Let's get these x's together. So I'm going to add 16x. That cancels out. This gives me 28x equals 336. And we divide both sides by 28 to solve. X equals 12. Okay, and this is examples of the angle bisector theorem. Remember, to use the angle bisector theorem, you have to have a line, like we do here, cutting an angle into two equal or congruent angles. Two congruent angles. Two congruent angles. When this happens, we can start setting up proportions. Just make sure you match them correctly.